going to be looking at graphing lines, and initially we're going to set up the points in a table and then look for a generalization. So when I look at my first line, my output is f of x, and my output's going to become from taking 2 times x plus 1. Remember, x is my input. So we're going to pick some values here. We're going to pick some easy values to put into my rule. We're going to plot them and see what happens. So remember, x is my input. It's going to go right in this position. So I'm going to take f at -1, and I'm going to input it in to this x position. F at 0, again, I'm going to input it into that x position. And lastly, f at 1, input into the x position. Simplifying each of these, 2 times -1, remember your integer operations, is -2. -2 plus 1 is -1. 2 times 0 is 0. 0 plus 1 is 1. And 2 times 1 is 2. 2 plus 1 is 3. So we've just formed some ordered pairs. The ordered pairs that we're going to be graphing happen to be when I put in -1 for an input, I get out -1. When I put 0 in as an input, I get out +1. 1 in as an input, I get out 3. Plotting these on the grid so I can get a picture of this line or function. Plotting -1, 1, x-axis, y-axis. -1, left of 0, 1. -1 in the y, down 1. So here's my first ordered pair. 0, 1. 0 in x, +1 in y. 1 in x, and +3 in y. Now if you notice, if I continued this, it has a constant change to it. And I'm going to go ahead and connect those dots, and I just formed a line. Now when we form a line, there's really two things we're going to be looking for: the slope or the slant of the line. And so if I try to determine the slope of this line, slope is defined to be rise over run. I'm going to pick any 2 points. And I'm going to find out how high did I rise and how far over did I run. I rose 2, I ran 1. I rose 2, I ran 1. So the slope of this is rise 2, run 1, which is equal to 2. My y-intercept, where does my graph hit my y-axis? My graph hits my y-axis at this point, and that point has an ordered pair from the origin, which is located here. The origin is 0, 0, so this point is 0, 1. Now if we take a look at my equation, what we want to do is see if there's some relationship between the equation and the graph, so I don't have to build this table every time, although this table can be built to graph any equation. If you notice, a 2 is sitting in front of the x. It happens to be my slope. The y-intercept of 1 happens to be this point right here, the y-coordinate. Let's try another example. Once again, putting in a value into my function. It says take that value and subtract 3. So the inputs we're going to choose again are -1, 0, and 1, because they're nice, easy numbers, and I've included 0, which is a special value that we want to be able to interpret, and then also -1. We want to include some negatives. Putting -1 into my function, my rule says -1 minus 3. Using your integer operations, a -1 and a -3 is a -4. F at 0, putting 0 into my rule, 0 minus 3 is -3. F at 1, 1 minus 3 is -2. Plotting these values, plotting these ordered pairs, we're going to pair them up first, x comma y. Those are my directions. X runs horizontally. It says go to -1, which is to the left of 0, and the y says -4, which is downward. Once I get to that location, I put my dot. 0, -3, 0 in x, -3 in y. Again, we're counting down 3, just like a number line, and over 1, down 2, puts me in this location. Again, I have a line, a linear equation or linear function. Determining the slope, slope is rise over run. Finding any single point, How many did I rise? How many did I run? How many did I rise? How many did I run? Looks to be like I rose 5 and I ran 1. Rise 1, run 1. Reducing that fraction is a 1. If you notice, the 1x is sitting right there. Sometimes we don't show the 1, so they are matching up like they did in the first case. If I remember, this is supposed to be my y-intercept. Looking at my graph, it is in fact my y-intercept. My y-intercept is the ordered pair 0 and x, negative 3 and y. Notice your y-intercept is an ordered pair. Trying this again, let's try with some fractions. When we pick our input and output with fractions, we want to be strategic so we don't have to do more work than possible. F of negative x, negative 1/2 x plus 1. So my input, I'm going to choose to input negative 2. Again, I want to try negatives, and I chose this 2 because if I have negative 1/2, I'm multiplying by negative 2 my input. The two negatives, when I divide, will make a positive, and 2 divided by 2 is 1, so 1 plus 1 is 2. Trying 0, putting f at 0. We need to go back and actually look at this first one again. My function isn't negative 1/2, my function is positive 1/2. So let's retry that here. My function is 1/2 x plus 1. 1/2 times negative 2 plus 1 would be negative 1 plus 1, which is 0. Applying 0 as my input, taking 1/2 times 0 and adding 1 gives me an output of 1. And the last one we'll try is a positive number. Let's try 2. 1/2 times the input of 2 and add 1. 2 divided by 2 is 1. 1 plus 1 is 2. So my ordered pairs then are negative 2, 0, 0, 1, and 2, 2. Plotting those points, negative 2, 0 in the y, 0 in the x, 1 in the y, and 2 in the x, 2 in the y. Again, you can see that when I connect those dots, I get a linear equation or graph, and I'm looking for the slope. The slope is a rise over run, a rise over run. I'm rising 1, running 2, 1/2. Again, it matches that position. The y-intercept is located right here graphically. I can see that it's at 0, 1. Notice my y-intercept is 1.